So now we will look at some of the use cases that we typically find for Internet of Things, and you can imagine there are many, many more. This is just a show of a couple of examples. So we also built some of these examples in our group work, and so the reason actually why we didn't look at the use cases before we came up with our own group projects is because you you might be prior into these use cases that you've heard about, and sometimes it's better to start with on a blank page and think about what you could do with these devices. Of course, you always have some use cases in mind, but when we talk about 10 different use cases in particular, it's very likely that some of you will have these in mind when we brainstorm. So that's why we definitely want to look at the use cases after we define the group work project, and this is a good point now to do that. So so this is what we would usually have done in preparation for our group work as well. So do a short brainstorming where we can use IoT to achieve a higher degree of automation. So that's the whole idea of using sensors and actuators, as we've seen in the last session. The whole idea is to be able to interact with the physical world. So on one hand, we get information from the physical world using sensors, and on the other hand, we use actuators to actually act in the physical world. And then in the middle, there's a piece of software that will connect both. So we can use the sensor data in our software to control the actuators. And basically, we automate some process with that. So for example, the greenhouse controllers is a very, I think, good example that everyone can relate to. There's sensors in the greenhouse, and based on the value of the sensors, we can control watering, we can control the sun blinds, we can control maybe windows opening and closing, and all kinds of things. And there actually doesn't have to be a human involved anymore once we have a good piece of software and a working application. Of course, there can be still, so maybe we have a dashboard or on a tablet or laptop where we control some of the things manually, or we get alerts, stuff like that. But in principle, once we have digitized these processes, they could run autonomously. So, and that's the ultimate goal, or the ultimate thing that we're trying to achieve when we use IoT technology, or basically when we connect these different devices and equip them with sensors and actuators. So just from the top of your head, what other use cases can you think of where this is very useful? Not the ones that you are currently working on in your group, but maybe some others that you have in mind. Is there anything that you can share?
I heard about the washing machine where it orders new washing stuff when it's empty or something like that.
So
Sure.
there is this smart washing machine example. I'm not sure what it does either, but it has to do with it tells you that something is empty and it will automatically order it. I think this might be some washing machine where there's a stock of things included, and it will tell you when it's empty. And the same goes for refrigerators. For example, they can you can equip refrigerators with sensors or maybe cameras, and they can automatically detect the things inside, and they could tell you what's inside. And then, of course, once they know what's inside, then they could also automatically put an order on Amazon or something like that, Amazon Fresh. Yeah, that's one example, and there's even one that you can use at home. It's I don't know what they call it. It's the Amazon Dash button, I think. Yeah, so you can order these small buttons, and basically they are connected to the internet via your Wi-Fi, and you can, for example, place them anywhere in your home, and you can program these buttons to place an order on Amazon, for example. When you put it into your, I don't know, on the side of your washing machine, you could program it to order your favorite washing. I don't know what the word for it is, but you know what I mean. So where you wash clothes with, what you put into the machine. So this is one example that is quite popular, and everyone can imagine because it's from our own use cases that we usually have at home. So is there anything else that you can think of or that you know of and that you would like to share with us? So I think the smart home thing is of course something that you have in mind, but some of you are actually building something smart office, smart stable. So it's all basically about controlling something in a room, and this can be your office, this can be your stable, this can be your, I don't know, your own home, and there can be sensors and actuators that do something like close windows or turn down the heat or turn up the heat, turn on lights and stuff like that. We all know this application, but there's of course also a lot of other applications, and also many applications in industry. And so we want to look at some of them now to get a better idea of where we can use these kinds of applications. So one I think that's very interesting and very useful is the so-called smart vending machine. And you notice that many of them start with smart. So basically, we call something smart once it can give us information about its own status and act autonomously. So the idea here is similar to the refrigerator that we just talked about, that it can detect or keep stock of the items that it has, and it will know when an item is running out, and then it can, of course, automatically place an order, or at least inform somebody that it is out of stock, and then this person could place an order. Of course, the higher automation would be to automatically place the order. And so there, but you can do even more. So you could, for example, or what is already done is track the sales transactions, and then you could send these sales transactions, for example, to a central server, and you can then monitor at what times is the machine being used the most. And you could even think about adjusting prices based on the time. So maybe at night when nobody's buying, you could offer lower prices, and during times where it's very high frequented, you could increase the price, so you can react flexible to the demand curve, which is of course something which allows you to maximize your revenue at this point. And failures, of course, if the machine is broken, you can get automatic alerts, and so this basically improves the whole maintenance process, because then somebody will automatically know and will come and fix it. And maybe you can even implement something that's called predictive or preventive maintenance, where you don't even let the machine fail, but you rather recognize in advance that it will fail soon. That, for example, a crucial part is going to be broken soon. So you can use different sensors for that, or just basically the time that the part has been in. So you will tell somebody it needs to be checked, because we know after 2 years this part will break. So basically what you can do is do something like predictive maintenance or preventive maintenance, so the machine doesn't go out of order at all. And that's, of course, again, saving you money and saving you time. So this is, I think, a very intuitive example where this could be used. But I think that most of the vending machines that I see today are not really smart. So most of them are not smart vending machines, but this is something that you could do with today's technology already, and to some degree it's of course done. So then I think you've all heard of one or another form of this intelligent supermarket idea. So in Germany there exists a Metro store, I think, who has implemented this, and Amazon is testing these stores where there's no human anymore in it, and where you don't need to go through a cashier at all. So all these ideas involve IoT technology, and here the idea is, for example, in this case, you have a shopping cart and there's a display integrated, and the products that you can shop in the supermarket have, for example, RFID chips, and these RFID chips can be read from a distance. And once you put it into your shopping cart, the shopping cart can read the RFID chip and then automatically update your digital shopping cart on the display and show you the total amount that you're going to have to pay when you walk out the supermarket. So there you have the idea of removing the cashier altogether, because when the shopping cart knows what's inside of it, and it can automatically purchase the order from your credit card because you have an account with the supermarket, then this can be automated as well. So there's also a chance to, for example, let you know that certain goods are behind their best before date. So you could automatically have staff remove those items. This will, of course, be much more efficient than having to go through all the items and check the best before date and stuff like that. Paying with fingerprint and contactless paying is already a state of the art in most supermarkets and even now the smaller shops. With COVID-19, everyone offers contactless payment, which I think is one of the benefits of this whole thing. But this has been around in the larger supermarkets for a long time, and now paying with a fingerprint or with your smartphone is also so fingerprint I haven't seen, but smartphone is a very state-of-the-art thing as well. So you simply use NFC and place your smartphone in front of the reader, and it will process your purchase. So there's also potential in supply chains. More general here, it's about food safety, and this can be seen as a supply chain topic. So when you have somebody who produces the meat, or in this case meat or any other product, and this needs to be kept cold, and you can of course employ sensors in different, for example, in a truck or in some box that you use to transport the good, and this could be automatically documented, for example, using a central database or even blockchain technology, which is basically a distributed database, which is hard to manipulate. So, but the whole idea is that we use sensors to measure temperature or other physical or environmental KPIs. So this could also be the humidity, the temperature is of course very apparent for food. This could be sunlight if your product is very sensitive to sunlight. And you can measure all that and then automatically document that and automatically create warnings or alerts if there is some violation. For example, the temperature got too high for too long time. This can then be automated, and we can automatically or we can improve our quality checks, because then we know which products to check, because we know that there has been potential violation of for example, the cool chain. Is that what it's called? Yeah. So basically, you can imagine sensors being used here, and then a piece of software that monitors the whole thing, and then an automation process behind it. Theft prevention is another one that's actually being offered. I forgot the name, but it's someone that we have worked with at the university here. He offers a digital platform for farm management, basically, and they also offer a physical device. And this is the screenshot is from their website, where you put a physical device on your machine, and then the physical device is basically sending the GPS data to a central server in real time, and you can then define via a user interface a certain area where this machine usually is, and if it leaves this area, this will be interpreted as a theft or some irregular event that should be monitored, and then the owner can get a in this case a short message or a WhatsApp message or whatever it is, but he or she can be notified. And this is based on sensors, in this case a GPS sensor, and then of course a connection to a mobile network, and sending the data into the cloud to process it, and then alert the owner or the user. So this is also a very useful use case for IoT. So when you think about animals or farming in general, you can track animals, or you can track anything, but animals is one of the use cases where you can learn a lot about. So, for example, this is from, I forgot the name of the product, but they offer a suit to track your, in this case, herds of cows. So you can put sensors on your cow, and they will be tracked. They track their movement, and basically their so where they move and how they move. And whether they are lying or standing. And from that data, if you have a lot of cows and you analyze that data, you can derive patterns. So you know what's a normal behavior or a normal pattern or for a cow. And then you can also, of course, easily identify anomalies and outliers. And these can then be picked out and checked again. So if there's, for example, a disease and the cow is sick, then you can very quick identify the animal and take it out of the herd, and then take the necessary measurements. So this is, of course, more important when you have a large number of animals, and it will give you many insights also about the behavior. So where, for example, to put, places where they can drink or where they can get food, because you can optimize that based on the behavior of the animals or the movement of the animals. So this is another use case that's coming from the farming industry. That's also interesting. And of course, the smart greenhouse, I think we've talked about that enough. So just very quick, different sensors in a greenhouse. And then you can have, for example, what's often done is providing a dashboard that basically, first of all, lets you monitor the data in the greenhouse, but then also lets you, of course, control some of the parts in the greenhouse. Or as I said, you can have an automatic control system. Or parts of it can be automated. And in this image here, they offer also an Amazon Echo or basically a voice assistant support. So you can also talk to your control center and then have voice commands do something in the greenhouse. So for example, you could shut a window using a voice command, and that's also often found, or more and more found, in IoT use cases, that you don't use dashboards or anything to control things, but rather you use your voice assistants. And also in smart home, you will often find that with Google Assistant, Siri, Alexa, stuff like that, which can control, for example, your light very easily, and that's more and more coming. So that's just some of the use cases. As I said, there are many more depending on the industry that you're looking at. These were all use cases from either the agriculture or food industry. So if you think about other industries, there's of course many more use cases, and there will be many more use cases with the technology being advanced and also software being advanced. So for example, in the area of artificial intelligence, we see great potential for applications in combination with sensors and actuators, because the part in the middle, which is the software, where we have a human in the loop that needs to decide something. Once we can automate that, we can achieve an even higher degree of automation, and that's where artificial intelligence comes in, where machine learning comes in, and this is what we're going to talk about starting next week, and then we will also learn about use cases for that, and also integrate some machine learning into our own projects later on. So related trends to Internet of Things. So you hear sometimes the buzzword big data. Big data is a term that has been around for years now, and it has been defined to, as the name suggests, first of all, big volumes of data that we haven't had previously. And why do we have that growing amount of data today and in the past years? Well, the main reason is digitization and digitalization. And of course, sensors play a role in that as well, because sensors do nothing else than produce information, basically. And they create digital information that needs to be stored, that needs to be transmitted, and that needs to be processed ultimately. And this is why we can relate the whole big data trend also to IoT. So it's also closely related to the internet in general, and to social media, social networks, people creating content online, where there's a lot of different and unstructured content. So for example, text, images, video, audio, that we can also process. And this is all subsumed under big data, but sensors play a big part in it as well, because as I said, it's mainly about the frequency and the volume of data that is created by sensors. And you can imagine if you have a real-time sensor that is sending you data in milliseconds, and you want to actually have a very real-time alert system based on that, and you have a lot of sensors, you need a good infrastructure and good solutions to process that data in real time. And this is where technologies of big data processing come in. And this is where it's related to our current topic, Internet of Things. Then, as I already said, artificial intelligence is also closely related. Here is the example image of Lee Sedol, who in a couple of years ago famously lost to AlphaGo, which was one of the milestones or breakthrough in artificial intelligence. I don't know if you're familiar with that, but basically Go is a very thought to be very complex game, and it's a very complex game with endless possible moves. So basically, when you try to calculate every possible move, there's no way you can even begin to do that. That makes it also different from chess, because in chess it's actually possible to calculate many moves ahead just by simply laying out all the moves and finding the best. In Go, this is not an option at all. So the problem is much bigger, and we thought that it would take much longer until machines could beat us at or not us, but the best players in the world at Go. And Lee Sedol was one of the best players in the world, or is. And he got beaten a couple of years ago, famously and dramatically. So the machine won 4-1. So he only won one of the matches, and that was a big push and also a big breakthrough for the whole movement of artificial intelligence. And that's why we see this image here. But in general, the idea, as I said, is always the same. We want to teach machines or digital computers to perform tasks that before only humans could perform. And we get better and better at this, and machines can do more and more. And there are still some things that machines can't do, but there are many, many things that they can do, and sometimes can do even better, sometimes worse. But there is a lot of potential, and this is, of course, related to IoT, because simply in IoT there's so much data that we can use to train machine learning models. And as we will see starting next week, artificial intelligence today is based on, or needs, is very hungry for large amounts of data to work. And in IoT, we have this data, we generate a lot of data using the sensors. And of course, we can then, when we want to make decisions based on the sensor data, we can then train an artificial intelligence to automate a certain decision that before only humans could do. And then maybe the hope is that the machine will do it even better and make smarter decisions. So this is why artificial intelligence is related to IoT as well, and there's great potential in it. So I mentioned blockchain before. Blockchain is something that you may have heard about in the context of Bitcoin, the cryptocurrency. And that the technology behind Bitcoin is blockchain. And blockchain is basically, as I said, a distributed database which has the property that once you made a transaction in a blockchain system, because it's distributed and because many people or participants verify this transaction, it's very hard to manipulate it, or it's basically impossible to manipulate transactions once they have been made. So this makes it a good technology for all processes where we before had a man in the middle scenario, so where there was a third party, a third trusted party that made sure that the transaction between two people was not tampered with. So for example, banks play this role in our economy. They transfer money, and they make sure that the transactions of money, when I send money to somebody of you, then the bank makes sure that the money actually arrives in the amount specified at the person, at the recipient. And this is a third party. And the idea, so there are many other use cases where we have the dependence on such a third party to ensure that transactions work properly. And with blockchain, there is a chance to remove this third party and have it also automated and digitally secured. And this is something where we can also have use cases in IoT. For example, when we want to authenticate IoT devices, you can imagine that a small device such as a Raspberry Pi with some sensors, or maybe even smaller devices, when they send information across the globe in a company network, it's important that this device can authenticate and tell the other device who it is. And how do you establish that trust? And blockchain will play or can play a role in that as well. So, because the importance here is when you have many millions of devices and they need to talk to each other, there's room for hackers or for outside attackers to intrude into the system and introduce devices that are not actually part of the company network. And so you need to make sure that the devices can authenticate and that there's a third party that can issue this trust. And this is where blockchain might play a role. And also there are use cases where it already does. You can then also use verification of data and commands. So when you send a command to a IoT device and it's maybe something critical, like shutting down a nuclear plant, so you want to have very high security standards for that. So not somebody from outside can do that. And there you also need some way to authenticate or authorize the commands that are coming in. And this is all use cases. These are all use cases where you can potentially use blockchain technology to solve them. And there's also a link to a article on CIO.com. So I think this is now already a couple of years old. So blockchain is already moving down the hype cycle, and we will see whether it will be put into production more widely, but it was hyped much more a couple of years ago, and this is, I think, where the article is coming from. During the hype a couple of years ago, 2 or 3 years ago, it was much more hyped. And now we will see whether it will actually become something that we will see being used more widely.